Hey everyone, quick question for you. If I drop these two balls at the same height, at the same time, which one do you think will hit the ground first? The basketball, right? Because it's heavier? Well, let's find out. They hit at the same time. Now you might be thinking, wait, that can't be right. Heavier things fall faster, don't they? If you thought this, you're not alone. This is one of the most common misconceptions in physics, and today we're going to understand why things fall the way they do through one of the most fundamental forces of the universe, gravity. So what exactly is gravity? Now let me ask you this. Why do things fall down in the first place? Most people think gravity is just the thing that makes things fall to the ground. And sure, that's part of it, but gravity is actually so much more than that. Here's the big idea that changed everything. Gravity isn't just the Earth pulling things towards the ground. It's a force of attraction between all objects that have mass. That means the Earth is pulling on you, but you're also pulling on the Earth. Your phone is pulling on you. You're pulling on your desk. Every object in the room is pulling on every other object in the room. In fact, you and I are gravitationally attracted to each other right now. Pretty wild, right? In 1687, Isaac Newton figured out the exact rule for how gravitation worked. He called it the law of universal gravitation, and here's what it says. Now this is the complete vector formula for gravity. Don't worry if it looks intimidating. Let's break it down. The negative sign in the r hat tells us that gravity is always an attractive force. It pulls objects together. The r hat is a unit vector pointing from one mass to the other. For this video, we're going to focus on the magnitude of the gravitational force, so we can write this more simply as, this equation tells us the strength of the gravitational force between any two objects. Let's break this down together. F is the magnitude of the force of gravity. m1 and m2 are the masses of the two objects, and r is the distance between them. That g is just a constant, a really tiny number that makes the units work out. Here's what this equation is telling us. The magnitude of the gravitational force gets stronger when objects are more massive. It's weaker when they're farther apart. Okay, let's test our understanding. If you double the distance between two objects, what will happen to the magnitude of the gravitational force between them? If you said that the force will become 1/4 as strong, you're absolutely right. If you double the distance, the force becomes 1/4 as strong. Great job. Now you might be wondering, if everything is pulling on everything else, why don't I feel pulled towards my desk? Why don't these two balls attract each other? Great question. Look at that equation again. See how g is an incredibly small number? For everyday objects like you, me, and these balls, the masses are so small compared to Earth's mass that the gravitational force between us is tiny, way too small to notice. But Earth? Earth has a mass of about 6 trillion kilograms. That's why Earth's gravity is the only gravity we notice in our everyday lives. So now we understand that gravity is a force between masses and how to calculate its magnitude. But we still haven't fully answered the original question. Why do these two balls fall at the same rate despite Earth pulling on the heavier one harder? It's a great question, and it has to do with how forces cause accelerations. We'll explore it in the next video, where we'll discover the value of g, the acceleration due to gravity, and understand exactly why all objects fall at the same rate. So let's review what we learned today. Gravity isn't just the thing that makes stuff fall down. It's a universal force of attraction between all objects with mass. Newton discovered that this force depends on the masses of both objects and the distance between them, following the law of universal gravitation. The magnitude of the gravitational force follows an inverse square law. Double the distance, and the force becomes 1/4 as strong. In our next video, we'll combine the gravitational force with Newton's second law of motion, and finally understand why all objects fall at the same rate. Thank you for watching, and remember, physics is all around you, You just have to look at it from the right angle.